Hello guys and welcome to this lesson. Today we're going to be doing a data analysis project. I have imported pandas, plotly express and plotly graph objects, and I'm just going to run this, and I'm going to be working with a data that I got from Kaggle, and this is basically the data. It's a student performance data, and there are 2,392 rows and 15 columns. And so we are going to do some data cleaning, and then afterwards just do some analysis to learn the rudiments of pandas. And so to first off, this is how the data came, how I downloaded it from Kaggle. So I'm just going to check info. Info allows us to check some basic things about the data, and things like the null count, the non-null count, and the D type. And so we can see that I think every single column in the data has all the values are non-null, right, for each, and because we have 2,392 rows, and then each of them have 2,392 non-null, so each and every of the column are non-null. So for that, it's already aside, but you can see here that each and every of the D type is between int and floats, right? So it's between int and float, and I think that will be an issue here. So the student ID is integer, and then age is integer, which should be so. But gender is categorical. However, 10 is not bad in terms of like a project where you need to build a model, a machine learning model. In data science, you need to convert all the columns to codes like this, but we want to do some analysis, and I'm going to take advantage of this to use certain features in pandas. And so what I would do now is I'm going to create a catalog. It's going to be a dictionary, and for each of the categorical columns. So I'll start with the age, and it's just going to be a dictionary of dictionaries. And so the age, I'm going to put in the initial value or the initial categories for them. For the age, now we see that, and for rather not the age, the gender. For the gender, so now for the gender, you see how that it's 1 and 0, right, which is male and female, right? So, and I have the data here. So for gender, it says 0 is male and 1 is female. So I'm going to come here and say 0, and I'm going to put male, and 1, I'm going to put female, right? You can say MF, whichever way, right? So and then we'll go to the next one, and the next category is ethnicity. So ethnicity, and it's a dictionary of dictionaries, and it has numbers from I'm just going to check the data here. So the ethnicity has numbers 0, 1, 2, 3. So I'm just going to copy this because it's already in kind of dictionary format. I'm just going to paste here and move everything forward here, and put some kind of comma in the dictionary. Yep. Okay, so I don't need to put comma here. So I'm just going to make these strings. What happened? Okay, so I'm just going to make this a string. So so I'm getting somewhere here. So now I have ethnicity, and the next on the list will be the parental education, which is also categorical, right? So I'm going to create a catalog. I'm going to create something for that. So education, It's meant to actually be strings, and it's a dictionary, and I'm just going to check on the data. So this is where I downloaded it from Kaggle, and it has 0, 1, 2, 3, 4. So I'm just going to copy this like this, and I'm just going to paste it here. Yeah, and then just so this I'm converting them to every single one to strings, and I'm doing this because of something which we'll see as. So this, I'm going to use double quotes here because it has a single quote inside of it, so I'm just going to use double quotes to just save ourselves a lot of headache. And so go on here, and then we have parental support. Yeah, so we have absences. Absences is actually meant to be integer. Study time weekly is meant to be float, so we leave it. Tutoring is something that we need to change. So tutoring, and it takes in a dictionary, and I'm going to come to check the tutoring. So it says 0 indicates no and 1 indicates yes. So tutoring just has 1 and 0. 0 no, and 1 yes, right? And so we go on to the next, which is parental support. So parental support, if I got the spelling right, and yeah, I think I did. Yep. When I mean spelling, I don't mean the English spelling, I mean the way it's spelled, like the way the column is spelled. If not, it would, give an error considering what we want to use it for. So, and so for the parental support, I need to come here and check, and parental support has 0 to 4, just like the parental education, right? So 0 to 4, and I'm just going to copy this here. Yep, and here we go again. Yep, so I'm going to just convert this to string, and then this to string, this, yeah, this puts it in quotes like that. So I think the rest would be way easier now. So then we have the tutoring, parental support, and the extracurricular activities. I think from the extracurricular activities downwards, they are all zeros and ones, which is no and yes. So extracurricular activities 0, 1, sports 0, 1, which is no yes, music 0, 1, which is no yes, volunteering. So they are binary columns because they have just 2 options. And so we just get straight to it. So extracurricular activity, just can copy here and just paste here, and just gonna copy this here, and I do the rest the same for sports, music, and volunteering, right? So sports, copy this, yes, and for music, yeah, music, so we have 0 for no, yeah, and 1 for yes, yeah, and then we have the last one, which is volunteering, which I don't know how it's spelled in terms of the exact. Okay, so the V is capitalized, and so come here and create volunteering, and we have, okay, so we have 0, which is a no, and then we have 1, which is yes. And so now we have everything in the column. I'm just going to run this to just save the dictionary, and I think it's done here. So we can create another code here. So now what we want to do now is we want to change each of these categorical columns, their values. We want to change the unique values in them to the alternative we provided. So for gender, we change 0 to male, change 1 to female, and to do that, we'll just look through the catalog. So the catalog is a dictionary which has keys and values, right? So keys and values. So key value in catalog.items, right? So you need to make it .items for it to return key and value. If not, it just returns the key. And then so the data frame, and then we put in the key, which is the particular column name that we're dealing with, is going to be equals to the key, and then you put in .map, right? .map, and then you put in the value there. And when we are done, just print the df for us. Now, great. So now I think we have changed everything we need to change. And so for gender, we have 1 as female, I believe. 1, yeah, female. So now you can see that we have changed the categories. Now we can check the info again and see the data. So we have int, and we have object. So initially it was just int and floats. Right now we were able to change it. Now let me just explain the code. Now notice how that's the value I put in the map function. So you can use map to for categorical columns where you need to change each of the categories. For in this case, in the gender column, we had 0 and 1. So that's why I created a dictionary. So most time it's a dictionary that is fed into that map method, right? So the key would be the initial value, while the value of the dictionary would be what you are trying to change the initial value to. So in the case of gender, wherever there's 0, it's changed to male, and wherever there's 1, it's changed to female, as indicated by the dictionary. So, and that's why when I use the map, so, and as I ran a loop, so it took the first key was gender, it took it and then it mapped the values, and so it changed 0 to male and 1 to female, and then it went to the second item of the loop, which is ethnicity, and it changed it to Caucasian and things like that. So now we can do a bit of analysis with this, because I think we have everything clear right now. So now to do some analysis, we need some hypotheses, and I think the center point would be the GPA and the grade class, because we are trying to see how every other information affects the GPA and the grade class. And to have a broad knowledge of that, we can use something in pandas called df.correlate. So core, it's called core, but its long form is correlate. That's so returns. Oh, okay, yeah, it's true. Yeah, because we have converted everything to objects now, we can use the correlate, and that's true. So I think we should have done that before. So I'm just going to rerun this here, and before I get the catalog, I'm just going to come here and then do df.correlate, right? And so it correlates it because it's numbers now. So the emphasis is GPA and grade class, and how the rest of the columns affect GPA and grade class. Now for student ID, the correlation is really low. So high correlations are towards 100, while low correlations are towards 0. And the correlation can be negative or positive dependent on the way in which that particular column affects the GPA. So these correlations are actually low, right? Okay, sorry, it's high correlations are close to 1, while low correlations are close to 0, right? And it can either be negative or positive. Now I'm going to use the absences. I can cite the absences here. So you can see the absences has a correlation of 0.91 to GPA, and it's negative. That means that with increased absences, there is going to be lower GPA. And with higher GPA, there's lower absences. And it's quite high because it's really close to 1, it's 0.9. And also, it's also correlates with grade class, which is 0.7, right? 0.7 is close to 1, so, and it's kind of positive. And I think the ones that come close again would be tutoring and parental support, which is not really high, but it's actually it actually is better off than the rest of the columns. Parental support, parental education also is really low, but we'll do some other analysis. So this is just to give insight. So now let's go deeper into creating analysis and creating charts. And I'm just going to okay, yeah, let me just create a code here, and I want to see how the absences actually affect the GPA. So I'm going to say I'm going to use the grade class, because the grade class is, I think, categorized. So I'm going to use the grade class. No, sorry, this is, so I'm going to group by. I have done a lesson on group by, and it's in the channel, and you can always go and check it out. So it's actually, you're going to see the link up there now. And so I'm just going to put grade class, and then I'm going to put in the, so the grade class is what I'm grouping by. So I'm going to be grouping by these grade classes, and then please give me a minute. Sorry. So, and then what we are checking is the absences. So absences, right? And we'll use the aggregate method, right? To aggregate, we're going to be putting the functions that we're going to be using to aggregate this absences column. So what we want to do is, for each of these categories, for each of the unique options in the grade class column, we want to see be it the average absences, or the maximum absences, the minimum absences, the sum of the absences. So we'll put sum, then we'll put mean, then we'll put maybe count. Yeah, so you can put the functions as strings, right? And I have all this explained already when I treated the aggregate function. So I'm just going to run this here, and we're going to see something here. So for the sum, you can see how that for 4.0 the absences are high, while for 0.0 the absences are low, which is strange. I think there is an error in the data we need to fix. So I'm going to check here to just confirm here. So it says 0 is okay, 0 is A, which is GPA greater than 3.5. Okay, so yeah, there's no error. So 0 is actually the best score. So 0 is actually best score. So 0 is best score, while 4.0 is lowest score, because I think we can check that, we can verify that right? So we can verify that very quickly. We can just use the group by. We're going to group by the grade class, and we're going to check the GPA, and we're just going to get the mean GPA. And I think it will be clear, but I'll just use the aggregate. So aggregate, and I'm just going to put mean inside of it. It returns a data frame which is better. So you can see for 0.0 the mean is 3.1. For 1.0 the mean is, okay, let me use max here. So 0.0 max 4.0, 1.0 max is 3.57, 2.0 max is 3.59, 3.0 max is 4, and 4.0 max is 3.9. Grade classification of grades based on GPA. GPA greater than or equals to 3.5 is 0, and like that here. So I think 0 is the best, while 4.0 is not the best. But I think there is a mixer, because 4.0 is not meant to have 3.97, because according to the data in 4.0 is less than 2.0 GPA. So when the GPA is less than 2.0, we have 4. So what we could do is we need to correct the data. So to correct the data, we would have to use an apply function. So def get grade class, right? So get grade class, and returns a call. It takes in an argument. The argument is each of the values of the GPA, and we're going to say if call. So we're going to use this condition here. If call is greater than or equal to 3.5, if call is greater than or equal to 3.5, then return 4.0, right? So no, sorry, return 0.0 according to here. So 0, which is GPA greater than 3.5. So return 0.0, and we'll say elif call is let's check that. So it's less than or equal to, is greater than or equal to 3.0 but less than 3.5. So call is greater than or equal to 3.0 and call is less than 3.5. So we return 1.0, yeah. And elif sorry, the code 2.5 and 3.0. So I'm just going to copy this time and paste here, and then this is 2.0, 2.5, 3.0, sorry. So 2.5, then 3.0, and return 2.0, then elif. So this would be 2.0, 2.5, yeah. So I'm going to copy this here. So, and this would be 2.0, yeah, and then this would be 2.5. And we're returning 3.0, and else, right? Else return 4.0. Now we can now apply this function. So df new grade class, and it's going to be equal to df GPA dot apply, and then we're going to just apply the get grade class. And when we are done doing this, we check the df. Great. So new Great. So initially we were getting it's almost the same thing here, but finally when it says 3.4, it's not meant to be 0.0 anymore, it's meant to be 1.0 because 1.0 is less than 3.5 and greater than or equal to 3.0. So this 2.1 is meant to fall under 3.0 according to this because yeah, it's meant to fall under 3.0. So I think we have ourselves a new grade class, and instead of new grade class we just use a new grade class here. Great. So now it follows a more reasonable sequence here because 0 is the best, which is 4.0. Okay, and then we run this here. So so if okay, it's still on new, so I'm going to use new grade class and run this. Now we can see it's now clearer. So 4.0, which is the worst, it has 26,000 absences. So it's safe to say that the absences affect the new grade class, the grade class, right? The grade class, and we can do something to show that. We can put it into plotly. So plotly.var, and just put hits here to see clearly. Great. So it's clear, but I would like the bar mode to be a little bit of group. It's not going to make any difference here. So let's just leave it like this. Great. So we can see here that the higher the absences, the lower the scores, right? 4.0 is the least possible grade that you can get, and you know they have more absences. So and then the next is 3, and then the people who have the best, they have little or no absences at all. And so we can, so that means it's really clear that absences actually affect the grade score. And then after that we could check for other things. I really want to check for, we have not done a catalog again since we coming. Okay, so let me run this. We did a catalog to make things clear. Yeah, and I'm just going to run this again. Yep. So now I want to check for parental support, how the parental support affects the grade scores and the GPA, how it affects the grade scores and GPA. And so let's go here. So df, we could use pivot tables also. Pivot table, and we have value. So the value is what you are grouping by. So it's the value is what you put here. Is it? No. The value is this, is what you're aggregating. That's the value. So what we are aggregating in this case is GPA. So we are trying to aggregate the GPA, and then we have the index, which is what you are grouping by. That's the categorical column that you're grouping by, which is parental support in this case. So I'm just going to copy this and paste it here, and you put in the add function, and I'm going to put in mean. Yeah, I'm going to put in mean. So let's see. So so I am going to sort the values, by mean. I'm just going to put mean. I hope it sorts. Yep, it doesn't. So the reason why it doesn't is because it has a multi-column here. It's not just mean, it's mean and GPA. So what we could do is get the columns. So the column is multi-index, mean and GPA. So I'm just going to copy this and sort values by I'm going to just put the two of them in strings and see what it does for us. Wait, so yeah, so it worked. So so because it has two columns, you just put the two columns in tuples, yeah, Python tuples, and then it sorts it. So you can see how that no parental support has. Okay, so let's make it ascending is false, so that it starts from the best. So yeah, very high we have 2.19, and then high we have 2.0, and moderate we have 1. So I think it actually goes down depending on the parent support. So I think parent support has something to do with it, but it's not, the difference is not so much. So let's see it in a bar chart. I'm going to use the px.bar so that we see it in the bar chart. Okay. Data frame content column is a pandas multi. Okay, so it said pandas multi is not supported by the plotly at the moment. So since it's a multi-index, we need to change the column. So so we can just save it as PS, which is parental support, versus mean GPA, and then change the column dot columns is going to be equal to mean GPA. So let's see what it does for us. Great. So now I think Plotly will not be angry that we used multi-index. So let's see. Great. So it worked. So now you can see how that it actually follows a downward kind of spiral, right? So it follows downward. So very high is the highest, very high parental support. They have average the average GPA, or the mean GPA here, average mean, is higher, and then for high parental support it's high also, but a little lower than the very high. And you see non-parental support, even if they had good grades, but it can't be compared to the very high. So I think parental support has something to do with the grade scores. Now we want to see these absences, what affects the absences, right? These are some things that we can do. So I'm just going to do this lastly, and I did this to show us how certain pandas features work, and then we can use it to practice it to do more and dig deeper into the data. So I'm just going to check what affects the absences. Why is it the student time weekly on the I don't want to check parental education for now. You could check that. I want to see if the gender and age affects the absences. So let's just try that. So df dot group by, and I'm grouping by the gender this time, and I have absences, and I would use the aggregates, and I want to see the sum. Give me a minute, please. I want to see the sum and the maybe the mean here. And so let's run this. So basically, there is not too much difference, right? Males and females are almost equal in terms of their absences. Now let's check the age and see if there is a reasonable difference in terms of age and absences. Okay, so I think I'll just plot this. So I'm just going to say px dot bar and just run it. Yeah. So this is age 15. Age 15 has the highest, but the difference is not so much. So we'll need to dig deeper to see how the age affects absences, right? But we were able to see from the correlations that we did initially, yeah, that absences actually have something to play. And then we also saw parental support and tutoring. We didn't check tutoring. Tutoring is not so high, but it's better than the rest, right? But the reason why, the major reasons to make show us a level of how to use certain of the pandas features, and it's a freestyle, and I'm really sure that you have learned one or two things. So we're going to continue next lesson. Thank you for watching, and bye.